Hello friends, it's Lakhyajit here and welcome to my channel Maths Tutor Lakhyajit Ojha, and our topic of discussion today is vector differentiation. So this is lecture number 7 of mathematical physics, vector calculus, and this is especially for MSc and BSc students, and I have provided the links of previous lectures in the description box, so please watch them for better understanding, because basics knowledge are very important, right? So if you think my videos are very helpful, please do share with your friends and hit the thumbs up button if you like my videos, and if you are new to my channel, please subscribe the channel and hit the bell icon so that you get notified when new video will be uploaded, right? And do comment as well, you like my videos or not, if you have any questions, because when you share, subscribe, like, you comments, and then you inspire me to create new contents, right, for you. So that's my request. So if you're new to my channel, please subscribe the channel and do share with your friends, right? So now before we start what is vector differentiation, let me take you to the screen so that I can explain, right? And in this video we are going to solve some problems also related to this topic, okay? So hope this video will help you. So let's start. So let's discuss about vector differentiation now. So suppose we have a point, now we have a particle moving from P to Q along this red color path you can see here, from P to Q. So the position vector when the particle at P at time, suppose t is equal to 0, when time is suppose t, right? Let me consider that way. The position vector is suppose r vector. This is the position vector when the particle is at P relative to this origin O, right? So imagine that way. Then when it reaches the point Q, then its position vector after time del t, right? After time del t, it's become suppose r vector plus del r vector, right? So this is the position vector after time del t, right? So the displacement from P to Q will be given by del r vector, right? So imagine that way. So let me write the things that we have considered in this situation. So now if you apply the triangular law, before I'm writing this, let me tell you how we have got the displacement del r vector, right? So if you apply the triangular law of vector addition, then you can see here OP vector plus PQ vector are in the same order, right? So if you add them, and according to triangular law of vector addition, you should get the resultant OQ vector, right? OQ vector should give the resultant vector, right? Because you see this OP vector and PQ vector are in the same order, and the OQ vector is in opposite order, right? This vector is in opposite order. So that's why according to triangular law of addition, so OP vector plus PQ vector should give OQ vector, right? That's gonna be the resultant of these two. This OQ will be the resultant of OP and PQ vector, right? Sum of OP and PQ vector. So that's why OP vector is given by r cap, PQ vector is this one, OP vector is r cap, then PQ vector is del r vector, right? This OP is r vector, right? And this one is del r, PQ is del r, right? So OQ vector, this OQ vector should be r plus del r, right? So OQ vector is equal to r plus del r. That's how we have got, right? So what we have done, we have applied here triangular law of vector addition. So now suppose, let me write what we have considered. R be the position vector of the particle, moving particle, at P with respect to origin O at time t, and let at time t plus del t, its position suppose is Q, so that OQ vector is given by r vector plus del r vector. Displacement will be given by PQ, that is from this relation we have got PQ is equal to OQ minus OP, right? From this relation we have got OQ minus OP is equal to PQ from this relation, right? So if you put the values of OQ, that is R vector plus del R, minus OP is R vector, right? Then R vector gone, you have got del R vector, that is the displacement. Therefore rate of change of its position with respect to time, that will be del R by del T. That's it is a vector, okay? It is also a vector. This term is also a vector. As t tends to 0, t tends to 0 means this time interval is very small. Suppose this del T time interval is very small, right? Then you can assume that this Q point approaches to point P. That means we have assumed this Q is very close to P, right? P and Q are very close, right? You can consider that way, close to each other. Then this, if this point is suppose Q, this is the Q, then you can consider QP as a tangent on this curved, on this path, red color path. This will represent a tangent to this curve, right? So you can imagine that way, right? And then the PQ becomes the tangent at P, defined as dr by dt, and which is going to be equal to the, right, limit del T tends to 0 del R by del T, and this gonna give you the velocity, right? This is gonna give you the velocity of the particle, right, which represents tangent as well, right? So now you see dr by dt is the differential coefficient. This is called differential coefficient with respect to t, which gives the velocity of the particle. And if you take the second order derivative of r, then you will get the acceleration, right? So now let me give you some formula of differentiation. Suppose we have f and g, these are vector functions. Suppose these are vector functions, and also vector functions of t, and also we have phi is a scalar function of t. Then we will get the following relations. If you differentiate the sum of these vector functions f and g, then you will get differentiation of vector function f with respect to t plus that of g also. Then next relation you will get, if you find the derivative of these two functions, dot product of vector functions f and scalar function phi, then you will get, using the product rule, you will get vector function f d phi by dt, then plus then scalar function phi, then you will get derivative of vector function, right? So then third rule, if you take the dot product of these two vector functions f dot g, then again you apply the product rule of derivative, then vector function derivative of vector function g, vector function f dot derivative of vector function g, and then plus derivative of vector function f dot derivative of g, the vector function g. Then fourth relation, if you take the derivative of cross product of these two, here also you can apply the same rule, vector function f cross derivative of vector function g, then again derivative of vector function f cross vector function g. So these are the relations, important relations, remember them. So now let's solve some problems related to this topic. Suppose let me take a question. The coordinates of a moving particle are given by x is equal to this and y is equal to this, right? Find the velocity and acceleration of the particle when t is equal to 2 seconds, right? Let us solve this. First let me write the coordinates. So these are the coordinates x and y. So if these are the coordinates of the particle, then the position vector of the particle is given by x I cap, y j cap, right? If you put the value of x and y here, you will get, this is the position vector of the particle, right? And if you differentiate r with respect to time t, then you should get the velocity. So velocity will be equal to derivative of vector r with respect to t, then if you differentiate the component x component, that is I cap, coefficient of I cap, then 4t will be 4, and derivative of t square by 2 will be t, right? Because derivative of t square means what? T square. If you find the derivative of t square, then 2 into t minus 1, t 2 minus 1, that means simply t, right? Divided by 2 to gone, only t left, right? So that's why you have got this result. So next, if you differentiate the next term, this term, then you will get this, right? So this is I j cap. So at t is equal to 2 seconds, so what will be the velocity, that is dr by dt at t seconds? T is equal to 2 seconds. If you put t is equal to 2 here, you will get this. If you find the magnitude, then you will get the velocity. 2 square plus 4 square, that is 20. Root over 20 is approximately 4.47. So if you find the acceleration, how to find the acceleration? If you differentiate this again, that means if you find a second order derivative of the position vector, then you will get the acceleration. Second order derivative of r with respect to time t. If you differentiate this again, then you will get minus I cap minus t j cap. At t is equal to 2 seconds, a will be equal to second order derivative of r with respect to time t at t is equal to 2 seconds will be given by so we are going to find a magnitude, right? So to get the acceleration, magnitude of the acceleration, right? So then minus 1 square plus minus 2 square, and that's going to be root 5. That's going to be equal to 2.24 approximately. That is your acceleration. So this is your acceleration. So hope you have understood this. Now let's move on to another question. So this is your question, next question. So let me write the question. So what we have here, so you have a particle moving along this curve represented by x is equal to 2t square, y is equal to t square minus 4t, z equal to 3t minus 5, where t is the time. Then we need to find the component of its velocity and acceleration as well. What component? Along this vector. This is another vector at time t is equal to 1, right? So first let us solve. Let me write the coordinates, right? Let me write the given curve, right? So the position vector of this particle will be given by this. If you put the values of x, y, z, then you will get the position vector this is the position vector you're gonna have of the particle at time t. So velocity is given by first order derivative of r with respect to t. If you differentiate the first term, then you should get 4t I cap. Next term 2t minus 4t, right? Minus 4. So if you differentiate this, you should get 2t minus 4. If you differentiate this, then what you will get, right? So 3t will be 3, and derivative of 5 will be 0, right? So where t is equal to so we have to take t is equal to 1 actually here, right? T is equal to 1 given. So dr by dt, that's velocity, will be given by this, right? What we have done, at t is equal to 1, we have put here 1. Instead of t, we have put here 1. So we have got this after putting t is equal to 1, right? This gives velocity. Now velocity along a given vector, along this vector. So how to find the velocity along this vector? How to find a component of velocity, component of this vector along this vector? It's very simple. So that's gonna be the vector of which we need to find a component, that is the velocity vector, that is given by 4 I cap minus 2 j cap plus 3 k cap into unit vector of the vector along which we need to find a component. That means unit vector of this vector, this one, along which we need to find a component, right? So you know how to find a unit vector, that's why I'm not explaining. So let me tell you. So this is your vector, right? We need to find a unit vector of this vector, right? So let me clean this word a little bit. So here you see So what we are going to do, just as we need to find the component of this vector dr by dt, that means velocity, along this vector, so we will multiply this velocity vector with the unit vector of this vector along which we need to find the component of the velocity, right? This vector gives the velocity, so of which we are going to find a component, and we are going to find a component of this vector along this given vector, that is I minus 3 j cap plus 2 cap along this vector. That's why we are going to find the unit vector of this. If you multiply the unit vector that is given by this result, unit vector with the velocity vector, you will get the component of this velocity vector along this vector. So how to find that unit vector? So as we are going to find the unit vector of this vector, you can see that I have written within the box, green box, this green box, you can see I cap minus 3 j cap, right? I cap minus 3 j cap plus 2 k cap, right, of this vector. So this vector, if you divide divide it by its magnitude, suppose you have a vector a cap, you need to find the magnitude, unit vector. How to find that unit vector a cap? That's going to be vector a divided by its magnitude. That's what we used to do, right? If the vector a is a x I cap plus a y j cap plus a z k cap, then how to find its magnitude? Then magnitude of vector a is given by root over a x square plus a y square plus a z square, right? So that's what we have applied here. So hope you have understood this. So now let me clean this part. Okay, now you see what we will get after doing so. Velocity along this vector, this given vector I cap minus 3 j cap plus 2 k cap is given by this velocity vector into the unit vector of this vector. We have got this root over 14. So if you multiply this one with this, then what you will get? You will get 4 plus 6 plus 6, right? And if you add the numerator, then what you will get? 16 by root over 14. Now let's multiply numerator and denominator both by root over 14 in order to rationalize the denominator. So then what you will get? 16 root 14 by 14. Then cancel 16 and 14 by 2. 2 8 is 16, 2 7 that is. So this is your result. This is the velocity component of velocity along this given vector. This is the velocity component along this given vector, right? So now acceleration. So that's going to be given by the second order derivative with respect to time of we are going to, that means if you need to differentiate the velocity again, right? Acceleration is given by dv by dt, right? And v is given by derivative of r, right? So you can write derivative with respect to time t of derivative of r with respect to time t. That means that's going to give you the second order derivative of r, right? This is your acceleration. So hope you know these kind of things. These are very basic things of differentiation and factors, right? So if you find the second order derivative, then you will get this. So hope you know differentiation very well. I have assumed that way, right? So then acceleration, let me write the acceleration again. We have got this. So here no variable t left here. T is not present here. So doesn't matter, at t equal to 1 or 2 you will get the same acceleration, right? So if you find the magnitude of this acceleration, so we are going to find the acceleration along this vector, right? So again we are going to find the component of acceleration along this vector, right? So the vector of which we are going to find a component, that write that one, that is acceleration vector. This vector gives acceleration, right? This gives acceleration. So write that vector first, then multiply it with by along which we need to find along this vector, so multiply it by its unit vector, right? So unit vector of this vector along which we are going to find a component of acceleration, that is given by the given vector I cap minus thrice j cap plus twice k cap divided by its magnitude given by this. So I have already explained that how to find a unit vector, so hope you have understood that. So here you see denominator is your root over 14, and if you multiply this vector with this one, then what you will get? You will get 4 minus 6 by root over 14, and that's going to be this. And if you rationalize the denominator, root 14 is multiplied with the numerator and denominator both to get the rational denominator. So then we have got this result. Now cancel by 2, then you will get this minus root 14 by 7. So this is the acceleration along, this is the acceleration component of acceleration, sorry, this is the component of acceleration, that is second order derivative of r vector with respect to time t along what, I cap minus 3j cap plus 2k cap, right? So hope you have understood. This is your result. So now let's move on to next problem. So next question is, find the unit tangent vector and unit normal vector at t is equal to 2 on the curve x is equal to this, y is equal to this, and z is equal to this, right? So here t is any variable, right? Now let us solve. Before we solve, let me write the given curve. So this x, this is y, and this is z, right? So what will be the position vector? So r vector is given by x I cap y j cap as x I cap plus y j cap plus z k cap, right? So if you put the values of x and y, then you will get this position vector, right? We know that what we have done, we know that position vector r vector is given by x I cap, right? X I cap plus y j cap plus z k cap, right? So we have used the values of x, y, z here, right? Simply these values are given values of x, y, z, right? So that's how we get the position vector, right? So hope you have understood this. So now tangent, what is tangent? Dr by dt, that means if you find a velocity, that gives the tangent, right? That gives the tangent. So how to find the unit vector of the tangent? So tangent, this vector r derivative of r vector divided by its magnitude of derivative of r with respect to time t. So this is going to give you the unit tangent vector, right? It's going to give you unit tangent vector. So hope you have got it. So let me clean this. So let me solve it now. So let's find the derivative of r, right? Tangent vector t vector gives dr by dt, right? If you differentiate the first term, you will get 2t I cap. Second term, differentiate it, you will get 4 j cap. Then third time, if you differentiate 4t minus 6 k cap, right? So at t is equal to 2, so tangent will be at t is equal to 2, this vector, above vector, if you put the value of t here, t is equal to 2 here, then you will get 4 I cap, 4 j cap, and if you put here t is equal to 2, then you should get 2 k cap, right? So unit tangent vector will be given by vector t by its magnitude. That means vector derivative of vector r with respect to time by the magnitude of derivative of r with respect to time. So if you do so, then this is the tangent vector, and its magnitude will be given by root over 4 square, 2 square, right? So if you calculate this, then what you're gonna have? 36. Root 36 is equal to 6, right? So that's why 4 by 6 I cap, you can write 4 by 6 j cap then 2 by 6 k cap, right? So if you cancel and simplify, then you will get this result. 1 by 3, take 1 by 3 common, okay, then 2 I cap, 2 j cap, k cap. So what we have done, we have taken, here you have 2 by 3, here you also you have 2 by 3, here you have 1 by 3, so you can take 1 by 3 common, then 2 2 1 will be left inside the bracket, right? So that's how we have got this. So this is what, this is unit tangent vector. Now let me find the unit normal vector. So how to get the normal vector? So unit normal vector, let me take this one. So unit normal vector will be given by derivative of tangent vector with respect to t by its magnitude, derivative of tangent vector by t. So hope you have understood, right? So we have already got the tangent vector, that is dr by dt, right? So this is the tangent vector, right? So here, to get the normal vector, unit normal vector, you have to differentiate the tangent vector and divide it by its magnitude, right? So if you differentiate this tangent vector, then with respect to time t, then what you will get? So the differentiation of 2t, derivative of 2t is simply 2. So here you will get 2 I cap, and derivative of 4 j cap will be 0 because it is constant, that's going to be 0, right? So and derivative of this, so here you have 4t, so that's going to be 4 only, and 6 will be 0, derivative of 6 will be 0. So that's why we have got 2 I cap plus 4 k cap, right? And its magnitude will be root over 2 square plus 4. Value of this root over 2 square plus 4 square, that is 4 plus 16, right? Root over 4 plus 16, that's gonna give you 20, right? So hope you have understood this. So now you see, if you simplify this, then what you will get? Root 20 can be written as 4 into 5, right? Root over 4 into 5, and square root of 4 is 2, that's why you have got 2 root 5, right? So that's why you will get 2 by 2 root 5 I cap plus 4 by 2 root 5 k cap, and 2 cancels 4, 2 gives 2, 2 cancels 2, right? So our result is 1 by 5 I cap, 2 by root 5 k cap. So this is our result, 1 by root 5 I cap, 2 by root 5 k cap. So this is what? This is unit normal vector. This is what? This is unit normal vector. Unit normal vector. That's how we got new unit normal vector. So how to get? First differentiate the tangent vector with respect to time t, then take the magnitude of the derivative of tangent vector, right? So let's move on to the next problem. This is our next problem, question number 4. Prove that derivative of cross product of these two vector functions f and g with respect to time t is given by this result. So this is the result, right? So how to prove that? Suppose this vector f is f1 I cap, f2 j cap, f3 k cap, and vector g is suppose g1 I cap plus g2 j cap plus g3 k cap, right? So now you see, let's find f cross g. So that's gonna be that's can be found out by using determinants, right? If you find it using determinants, then what you will get? So for I cap into you will get f2 into g3, then minus g2 into f3, right? So what you have got? f2 g3, then minus g2 f3, right? g2 f3. So f2 g3 minus g2 f3 into I cap, then minus sign, then f1 g3, then g1 f3 j cap, then plus k cap. How to find that? For k cap, f1 g2, this is f1 g2, then g1 f2, right? So this is your result. So that's what you will get. Now if you differentiate this cross product with respect to time t, then you have to differentiate each term, each component, right, with respect to t. This here we are going to apply to find the derivative of f2 g3. What we are going to apply? We are going to apply the product rule. Use this rule. derivative of u into v. So u derivative of u into v plus v u into derivative of v. So we are going to use the product rule here also, and here also we are going to product rule similarly here also, and here also you get you can use the product rule to find a derivative, right? So hope you have understood this. So now if you differentiate the component of I, then what you will get? Derivative of f2 z3 minus z2 f3, this is I cap, right? If you differentiate the first part f2 z3, then you will get f dot represents this f2 dot represents derivative of f2 with respect to time t. So that's it. So hope you have got it. Instead of writing that way, instead of writing this way, so I have written f2 dot, right? So hope you have understood this. This is what derivative, this is df2 by dt, right? So similarly what you will get, z3 dot, that means this is dz3 by dt. So hope you have understood this. So into f2, right? Then minus, if you differentiate this part, then you will get z2 z dot z2 dot f3, then minus z2 f3 dot. So this is what I kept. Similarly what we have done, let me regroup the dots on f and dots on z. Let me separate dots on f. So these two terms contains dots on f, right? Let me write these two together. Then let me write these two terms, here you see dots on z, these two terms into I cap. So similarly if you take the z component, then what you will get, right? So here you see, if you compare f2 with f1, z3, then z2 is z1, then f3 is f3. That means we are going to replace here f2 by f1, right? We are going to replace this f2 by f1 and z2 by z1. And if you replace f2 by f1 and z2 by z1 in this result, then you will get the derivative of this z component, right? So you will get this result. Similarly you can find the derivative of k component also, that comparing these two, f1 is f1, here z3 should be replaced by z2 and z1 is z1 and f3 is replaced by f2. So what we're going to replace here, we are going to replace f1 is remains same, here f1 is same, here we are going to replace z3 by z2, right? Then we are going to replace f3 by f2. Not only this term, here also we are going to replace. So then what you will get, then you will get the derivative of this k component, right? K cap. So hope you have got this. So now we are going to put these values of derivative of coefficients of derivative of I component row, derivative of z component and derivative of k component in this result. Here you see in this equation. Then we will regroup after putting those values here, right? After putting those values here in the above equation, above result, that derivative of f cross z, we will regroup the terms that dots on f and dots on z. We're gonna separate this, right? So these three terms will be written together because here these terms contains dots on f, and we will regroup these three terms. Here you can see this one and this one. These three terms contains dots on z, right? And after putting those values, after putting those results of those derivatives in this above equation, in this equation, right? So what we have got, we will get derivative of f cross z is equal to, after regrouping we have got this result, after regrouping this result. Right, now if you observe this part carefully, then this is the gonna be given by the determinant, this determinant I cap, j cap, k cap, and dots on f here. So f1 dot, f2 dot, f3 dot, and next row is g1, g2, g3. And if you observe this part, then you will get the determinant, this I cap, j cap, k cap, and here we have got f and g dots, right? f1, f2, f3, and dots on g, g1 dot, g2 dot, g3 dot. So here we have got f dots, and so that's why it is nothing but derivative of f with respect to t cross z, because here we are getting only z only, right? Not z dot. So that's why this determinant will represent this one. Then plus here we have z dots, you can see here we have z dots, so this is nothing but vector f cross derivative of z by t, with respect to t. So, or you can write this result that derivative of f cross z is equal to, so f cross dz by dt, then df by dt cross z. So that's how we can prove. So hope you have understood this. So these are the problems that I have shown related to this topic, vector differentiation. So do practice, and if you have understood, please do share with your friends and inspire me to create new contents for you. And if you are new to my channel, subscribe to the channel, and see you in the next video. So try other problems also if you have mathematical physics books, okay? And so hope you have understood this. So thank you for watching. See you in the next video.